RapidMiner is a software platform that allows users to conduct data mining processes, or basically search through large amounts of data to search for patterns or relationships between different variables. It is usually used in various business contexts, as well as in other fields such as research and education. RapidMiner also supports all steps of the mining process, from search, retrieval, and analysis to data visualization and validation for the results. The core of RapidMiner lies in its open source. Its open architecture allows the software to incorporate a variety of languages, thereby expanding the scale at which it can interpret datasets. It also allows the software to improve its analysis by acquiring new technologies. So where can you get the software? RapidMiner uses a client-server model with the server offered as software as a service or on cloud infrastructures. A starter edition of RapidMiner can be downloaded for free at their website. A personal edition is offered for US $999. A professional edition is $2,999, and pricing for the enterprise edition is available from the developer. RapidMiner is popular because it has an easy drag and drop interface. No coding is required, but users can code if desired, and it supports code languages such as R, Python, and SQL. RapidMiner also has a large community, and it's easy to get help if one gets stuck. RapidMiner is often chosen as the most popular data mining software amongst professionals. RapidMiner supports user insights from predictive analysis and implement in prescriptive analytics. Being an open source big data analytics platform allows contributions from other users of the community. One such breakthrough was the presentation of Xian, a specialist in natural language processing and text analysis. Instead of focusing on a statistical approach to text analysis, Xian was able to detect the irony and negative tones within a tweet or text. So what are some real-life applications of RapidMiner? RapidMiner allows users to churn rate and predict what type of customers are most likely to exit, and also calculate customer lifetime value. It analyzes tweets with sentiment analysis to see what users are saying about a certain subject, brand, or politician. RapidMiner has been used across a huge range of industries such as in automotive, banking, insurance, manufacturing, and telecommunications. Some of the users for the program include customer segmentation, predictive maintenance, quality assurance, risk modeling, and sentiment analysis. One text mining technology PayPal relies on is RapidMiner's predictive analytics and text mining software to help analyze historical and real-time customer data and predict what issues might prompt customers to abandon the service. Sustain Hub also applies RapidMiner for risk analysis in its supply chains.
So this is the interface of RapidMiner. When you start up the program, this is the first screen you will reach. This is the home screen. This is the landing page that allows users to navigate and load different functions of the RapidMiner program itself. There are some basic tutorials. There is an accelerator for those who want to just do data mining quickly with no customization, and this is where you start a new process. This is where you open your previous analyses. The second view, or perspective as it is called, is the design perspective. This is the main frame where you do all your customization of your data. We'll go through this more further on. This is the results screen. This is where you can see the results of your data. Here are our raw data. You can also view it in a statistics form, which you can open up and you can close it. You can view it as charts, and you can decide what kind of charts do you want to use. There are also advanced charts, which we won't go into today, and you can use annotations. The last view is the accelerator view. This is for those who want to do a specific task and no customization, such as direct marketing, churn analysis, predictive maintenance, and sentiment analysis. Now we're back in our main interface, the design view. The design view consists of different elements. The main part is our process element, where we build our algorithm and data mining process. We build this process by using data which we store in our repositories view. Here we can use external database and also local repositories and cloud repositories. This view is the operator view. This is where we can use different algorithms and processes for our data mining. Here's an example. If we want k-means, we can use k-means search to quickly load the operator into the process view. This view is the parameters view. This parameter view changes depending on what operator you're currently using. Now we're using the clustering operator, so in this view we can change the k value, for example. This view down here is the help view if we would need help during our data mining process. Welcome back. Now we're going to show a quick demo of how to do data mining in RapidMiner. So to start a new process, we click here and we come back to our mainframe window. But before we start with any data mining project, it is important to define the business problem that we want to solve with data mining. In this case, we have data from a hypothetical manufacturing company. This company is producing 22 different parts for automobiles. And it's an important task for the purchasing team to develop rational and reliable cost models for the product so that the marketing and sales teams can work from data instead of gut feelings. But, however, having 22 products makes it problematic because from a cost perspective, it's quite cumbersome to develop 22 different cost models, and that would lead to an unnecessarily complex situation for the marketing teams. So what the company can do, instead of creating one cost model for each of the 22 products, it can classify the products into a manageable handful of closely related clusters with products, with each cluster having similar attributes, and then develop suitable cost models for these clusters instead of everyone. So what we start with, because we have our product attributes saved in a Excel file. So what we do is, in a quick way, we write read Excel. And then we insert our first operator. We click it, and then we go to the parameters pane to the right, and we select our Excel file. Now the Excel file is loaded, and we need to scrub it with the import configuration wizard. We have already selected what file, so we just click next. And here we can select if there is any attributes, rows or columns that we want to deselect, but for this example we're going to use all the data cells. Here we get a quick overview of what kind of data we have in our file. To the left we have the product names of all the products. Here the rest of the table is different types of costs and variables for calculating costs, such as fixed costs and revenue for each product. In this next window, RapidMiner is calculating what kind of attributes we are using. Since this first attribute is the name of the product and not something that we're going to calculate, we select ID for this, but we'll leave the rest as attributes because they are going to be calculated. And as we can see here, the RapidMiner Studio has already defined these categories, and it does a quite good job at doing so. And all these categories are correct, so we leave them as they are. Then we press Finish. Our second step is inserting a k-means clustering operator. And here we can select how many clusters we want. In the cluster we chose 5 because that is a number that is within our economical scale of our marketing and purchasing team to develop cost models based on. So what we need to do now is connect the output to the input of the clustering model. And these are the same. What we're going to do now is to be able to evaluate our model afterwards and see how well the clustering algorithm performed. We're going to insert a performance operator. In this case, we want to know how well the distance performance is in this particular algorithm. And what we do after we've connected them from the read_excel to the clustering operator and through the performance measuring operator, we connect them to the results to the right. And then before we press the run button, which will go through our data mining process, we will just look through the files once more. We have our read_excel file, and it's imported and configured. Our clustering algorithm is a k-means algorithm, and we wanted to divide the file into 5 clusters, and it's going to do 10 maximum iterative runs, and we are averaging within centroid distance. So now we're going to press run to run the data mining process, and it's finished. What we can see here now is that we have 5 clusters, each containing a different number of items. To get into a more specific view, we entered the folder view. In the folder view, we can see that in the first cluster we have gathered these files. And if we want to, we could also look at each individual file and see its properties. The next one is the graph, where we can also see the files in each cluster. This is a quite small clustering exercise, so this view is not really relevant. If we want to go into more detail and depth, we can use the centroid table to see the centroid distance. And there is also a plot which we will not go into more depth in right now. But as you might have remembered, we also inserted a performance operator. So what we want to do now is check how well did it perform. And here we can see each single one and what average distance they have within each cluster. To get a better overview of what kind of centroid distance or distance between all the nodes and their centroid, we can go into this description view. And this all looks pretty good, and what we have now is our clusters. So what does this mean in practice? This means that for the marketing and purchasing team, what they need to do now is not make a individual 20 or 22 individual cost models, but they can do 5 cost models based on these clusters and their products within them.
This is another example of how we can use RapidMiner to do some data mining. So right now, what I have here is a CSV file on credit ratings as sorted according to age, education, gender, and their marriage status. So what we want to do here, as usual, we want to import our CSV file. So we go to our downloads and input our credit.csv. Make sure that it's comma separated. Go ahead and click next. Next again. We could choose to include the index, so we can exclude it this time. Everything else is correct, so we can go ahead, hit next, and we're gonna save it as a credit process. So back to the design window. Now we're gonna drag and drop our credit from the local repository into the process window. Now to do some clustering, again we look for the k-means cluster operator, and then we drag it and then we drop it inside. So we link the output, and then from here we link it to the results. However, now if you try to run the process, it won't work because it says that it contains non-numerical attributes like gender. So gender again is a categorical value, so the RapidMiner will not recognize that value, and it will not be able to run successfully. So one way in which we can subvent this is to introduce a different operator called a nominal to numerical operator. So we drag this in and we connect this. So right now, our categorical values like gender, marriage status will be labeled 1, 0, etc. So to show you what this means, we can also introduce another operator called write_CSV. Now this operator will let you see, will save an output file onto your whichever location you choose to save it to, and then you can go ahead and view the results. So if you click on write_CSV, you choose a location. Say I choose downloads. I'll name it credit output. Save it. Make sure it's comma separated, and it should be done. So if we run it, it should run as normal. Now back to the design view. If we go ahead and look at downloads, there will be a credit output.csv file that's generated after you've run the process. So if you go ahead and open it, you will come across the Excel file that now is slightly different from the original file because of the operator, the nominal to numerical operator. So right now you can see that gender for both male and female has now been categorized to 1 and 0. So that's another tool, operating tool that we can use in RapidMiner. Back to the results table. Again, the centroid table, because we chose k equals to 2, so we only have 2 clusters. If we want to generate more clusters, again, back to the design view, go ahead, click on clustering. We can amend the k value as follows. So again, if we run it, you will see that there will be 5 clusters, and again the output CSV file would be different.
Thanks for tuning in. I hope you learned something today. Bye!